Lesson 1, Unit 4, Functions and Function Notation. So before listening to this video, you should complete the Desmos Mystery Rule assignment. If this is the 2022-2023 school year, that is homework number 7. It's designed to do before these notes. Okay, so from that Desmos assignment, you can fill this out now. So pause the video and fill this out. A function is a rule that assigns exactly one output to each possible input. So when determining if a rule is a function, a table can be used to organize inputs and outputs. If one input has multiple possible outputs, then the rule is not a function. So let's look at these. So we have a rule. Rule H takes any measurement in meters and converts it to centimeters. So there are 100 centimeters in 1 meter. So we're multiplying each of these meter measurements by 100 to get the output, the centimeters. And here we put in 3 meters 2 times. And both times we got out the same output, centimeters. So this is a function. Check. Okay, Rule J takes whole numbers from 1 to 15 and outputs a word of that length. Okay, input 5 and an output is watch, because watch has 5 letters. Input 9, get vegetable. Input 9, get classroom. Wait a minute. Here we put in the same input, but got different outputs. So this is not a function. And you can fill this out down here. In this relationship, each input has, so for the first one, each input has exactly 1 output. So the input always comes out as 300. So it is a function. For instance, when we put in 3 meters, the output will always be what? 100 centimeters. Okay. You can fill this now in for this one. We decided this is not a function because each input had multiple outputs, right? There's lots of words that have 9 letters or 5 letters or 1 letter, right? That is not a function. And you can fill this out. Rule K takes any year and returns the last 2 digits. So the input is the year in 4 numbers, and the output is the last 2 digits. So put in the year 2009, get out 09. Put in 1915, get out 15. Uh-oh. Put in 2015, also get out 15. So let's see, is this a function? We put in 2 different inputs and got the same output. Is that allowed in a function? Let's see here. When determining if a rule is a function, okay, so a function is a rule that assigns exactly 1 output to each possible input. So this actually is a function. So it is a function because every time we put in, like if we put in 2009 again, we would get out 09. Anytime we put in the same thing, we get the same output. It is okay in a function if you have 2 different inputs that give you the same output. That's okay. Is a function. And then you're going to explain why here. So write a little bit more. Okay, on this one it tells us they are functions, and so we have to put in the remaining inputs and outputs. So it gives us a rule. Rule L takes a value and outputs that value plus 1. So every time you put something in, you add a 1 and get the output. So you do these ones on your own. Here it takes a value and outputs that value multiplied by 10. So anytime you put in an input, you multiply by 10 to get the output. This one you're going to have to go backwards. So you have to think, what is the opposite of multiplying by 10? All right, now we have a little practice here. We have to find the rule that is not a function. So pause the video and determine which one is not the function, not a function. All right, if you said rule R, you are correct. That is not a function because we put in 2 one time and got out 4, and then we put it in again, but this time got out a 1. Functions, you always have to get the same output for each input. The example we did in class is in a vending machine. Let's say the code for M&Ms is M3. You have to punch in M3 and that will give you the M&Ms. If you punch in M3 and get M&Ms, you're happy. If you punch in M3 another time though and you get pretzels, not happy. You're probably going to shake that vending machine and get really mad, right? That is not a functional vending machine, putting in the same code and not knowing what you're going to get. Okay, all of these other ones, if you look through, do have that, they are a function. Notice this one here, you take any word and output the number of letters. So it's all, whenever you put in at, it's always going to put out 2. There's always 2 letters in at. Now, we could find another input that would give us 2, right? What's another 2-letter word? How about the word on? So it's okay for 2 different inputs to have the same output. That's okay in a function. Okay, this next part is about function notation. Put a little box around that. Function notation is a way of writing the inputs and the outputs of a function. So our example here is a function for determining the price of a medium pizza. So we have the menu here, and we're going to zero in on the medium pizza. A medium pizza is $15.50 plus $1.50 for each topping. And so we could say, we're going to call it the function m. And this notation, if we say m parentheses 2, we pronounce it m of 2. What that means is that that's the price when we put 2 toppings on this pizza. So we could say m of 2 equals $8.50. And that means that the price of a medium pizza with 2 toppings, sorry, not 18, is $18.50, which makes sense, right? Because we're taking $15.50 plus adding $1.50 twice for the 2 toppings. Okay, you're going to write this here. What does m of 1 equals 17 mean? So it's going to be a similar sentence to this above, but it's a different number of toppings. Here's us putting it in a kind of an XY chart. We have number of toppings, and then we have the price over here. Okay, and now we're going to make the rule for this function. We're going to use an equation for it. So m of t, so t is the toppings, so that would be in this column here. I'm sorry, that is wrong. T would be this column, number of toppings. The price would be m of t, that column. So m of t equals 15.5 plus 1.5t, right? That's taking this information here about a medium pizza. And now we can evaluate m of 4. We can say m of 4, that means the price when there's 4 toppings. So we'll use the function rule, 15.5 or $15.50 plus 1.5 times 4. What does that equal? So that is going to be $15.50 plus $6. That's $21.50. All right, now we're going to make a new function rule, but for a small pizza. The small pizzas have different rules. The toppings are not as expensive because you don't have to use as much topping for a small pizza. So pause the video for a minute and write the rule for a small pizza, the price of a small pizza. All right, so if you said $13.50, or you can just write it as 13.5, either one it's okay, plus $1.25 per topping, which T is the number of toppings. And now we can evaluate S of 2, meaning the price with 2 toppings. All right, so you go ahead and evaluate that. The last part is some practice. Here we have an ice cream shop that serves ice cream in either a waffle cone or a bowl. Customers also decide how many scoops they want. So we have a function rule for the cost of a waffle cone order, where X represents the number of scoops, and then W of X equals cost of waffle cone order. So the value of W2, that means we're going to plug in 2 for X. 2 scoops. What's the price of a waffle cone order with 2 scoops? So we're going to plug that in, 1.25 times 2 plus 2.5. So it looks like it's $1.25 per scoop, right? And with 2 scoops, plus $2.50, that would be this part, for the waffle cone itself. Okay, and then you're going to do these other ones here on your own, and we'll talk about them in class.